that I'm not smart enough to understand, but I think through resistance it can tell what the temperature of that plug is, because things that are hotter are either more or less resistive to current. I'm not sure.
Yep.
But I believe that's how they do it. So it goes through, and of course everything's on a timer too. It's timing everything. So as soon as that glow plug gets warm, it'll pulse the fuel pump again, put some more fuel into the engine, and hopefully it'll start to see an EGT rise. And as soon as it does, it'll start to spin the engine slowly at first, because you don't want to blow the fire out.
Mm-hmm.
And then as the EGT begins to rise, the starter will kick in and it'll really start spooling that motor up. And it starts like if you've ever been on a full-scale airplane, sitting on the wing, you can hear them out there starting. It's basically the same process. The starter will spin the engine up until a predetermined RPM. That's determined by the manufacturer. At that RPM, the engine should be self-sustaining and the starter will disengage. And the engine will continue to accelerate up to and through its idling point. And on EvoJet, they actually accelerate the engine about 10,000 RPMs more. They call it a calibration acceleration. And it spins the engine up to, like on our 90s, it'll spin the engine up to like 65,000 RPMs and they'll let it settle back down into the 50s for idle.
Mm-hmm.
So, and then once that happens, once the engine goes through its calibration sequence and back to idle, then it'll transfer control of the engine to the pilot. Prior to that, you could move the throttle stick until your eyeballs popped out of your head and nothing's going to happen. So,
well, that's
once
probably
you
a
go
good
through the
idea.
calibration deal, it could be. Once you go through calibration and the engine controls turned over to the pilot, then the pilot has full control of what's happening. So,
is that just a normal notice, or is there some beeping, or how do you know when?
No, you'll know because you'll hear the engine RPMs roll back.
Right.
So when it goes through calibration, it actually accelerates slightly, and then it'll roll back, and you just hear it roll back.
Mm-hmm.
And then, of course, when you move the throttle stick, if nothing happens, you know you got a problem.
Right.
But for the most part, that's the situation.
Mm-hmm.
And then at that point, the pilot has full control. So how that works then is kind of like a fade back on a full-scale airplane, full authority digital engine control. What the pilot does is he moves his stick. When he moves his stick, it changes the microsecond count on the signal going to the ECU. And then the ECU responds appropriately, trying to bring this back into the null, if you will. So just like a servo, when you move the stick right and left, the servo follows it. Well, the ECU basically does the same thing except for it's electronically. And all it does is it says, okay, the pilot wants 70% power. And it knows what its 70% power setting is. So it takes the fuel pump, this little dude right here, and it puts more voltage to the fuel pump. More voltage to the fuel pump means the fuel pump spins faster. If the fuel spins faster, it pumps more fuel. More fuel, more fire, more heat, more spin, engine accelerates. It's pretty straightforward.
Mm-hmm.
So the only thing that the ECU is doing is checking the RPM, because it knows it has a defined RPM for any given throttle position. And it's checking its exhaust gas temperature via that EGT probe to make sure it's not over-temping or under-temping the engine. So it's a feedback loop. I put fuel to it, the engine accelerates, it sends back that acceleration data. The ECU sees that and says, I haven't accelerated enough. It gives it a little bit more fuel, and it continues to feed back on itself until it gets the engine running at the position that correlates with the stick position. So from full throttle to idle to full throttle, whatever that position is, you go into a feedback loop, and the system adjusts appropriately until it gets you to the position you want.
So does the controller have to be calibrated to a transmitter, because the microsecond count or USEX would be different? Yeah?
Yes, absolutely. Now, I got to be careful here because I don't know who's watching that flies JetCat, and I don't mean that in a bad way. I just don't want to say how JetCat does it because I don't want you to get 1 million people in the chat room saying that guy's an idiot. I've got limited experience with JetCat. I owned a P120. Another fellow helped me set it up, so I'm not 100% sure. But basically what you do is you have to put the ECU in a calibration mode with a handheld data terminal, which is, I don't have one handy right here, but there's a handheld data terminal that plugs into this that actually read data right directly from the unit. And then you tell like on EvoJet, you tell the system, okay, I've got the throttle all the way closed and I've got the trim all the way down, and you just say, okay, this is engine off, and you hit a button and it remembers the millisecond count. And then it asks you, it goes to an automatic thing. It says raise idle to trim, or trim to idle. So then you raise a trim lever to idle, and it has a different millisecond count, obviously. And you you hit store, and it stores that. And then then it asks you to move the throttle to full throttle. You move it to full throttle. That, again, is a different millisecond count, and it asks you to store that. You push the button, it's stored. And now the unit knows what the millisecond counts are for cutoff, idle, and max throttle.
Yeah, so it's basically the same thing as configuring an ESC in an electric plane, yeah? Similar process.
Very much so. Yeah. And then you can... Yep. Now, I run a straight linear curve. I do not run a throttle curve, as it were. The system itself has a couple of built-in factory default curves. I use those to control my engine, and I've had great success. But some guys use a throttle curve, which is to say that because on a turbine engine, 90% of the thrust is made in the last 10% of the throttle, if I'm making any sense.
Yeah,
in other words, at 80%, at 70, 60, 50%, you're making about 10% of the thrust in this example. But at 91 to 100%, you're making the remaining 90. I mean, I know those numbers are skewed off, but that's the general idea.
It's an exponential thing. Yeah.
Right. So guys will build throttle curves to compensate for the engine being exponential like that. I don't do it. I've never had a problem. Other guys do, and I'm sure if I got on some of these big warbirds, some big heavy metal stuff, I'd probably want to do that too. But as far as calibrating the engine, that's all I do is those steps like we just talked about, and it's ready to run. Okay. It's ready to go. So that's a turbine engine. I don't know if anybody's got any questions. I'll try to feel them. I'm watching the chat room. I don't see anything really coming up.
Prowler, you must have some questions there. Am I still online here with my chat room? It tends to drop out this other machine. Oh no, it's still there. Anybody there? I think they're all absorbing. Excellent, excellent description, Dave. Absolutely excellent.
Well, good. I'm glad. I just looked at the clock and saw that I've been droning on for 50 minutes now. It's pretty dang amazing.
Well, no.
My wife. I guess my wife's right. Oh, hey, one more thing I didn't show you guys. It's stupid little part, but it can make or break your day, and that's this dude right here. It's just an inline filter.
Mm-hmm.
Man, you got to have one.
For the
you
fuel,
cannot
right?
believe how Yeah, this is a fuel filter, right? Exactly. You can't believe how small the little capillary tubes are that actually distribute the fuel inside the engine. So these little filters right here, they catch any kind of microscopic garbage that might be going through there.
Okay, well, here's a question. When you say kerosene, you're not talking about just domestic kerosene, are you? Are you talking about Jet A or?
No, I'm specifically talking about kerosene.
Okay, that you
I know
can
there's
buy
a
in the
couple
hardware
of grades
store,
of it.
Well,
Absolutely.
Yeah,
and a lot of guys do. They'll go to the Home Depot or the Lowe's or whatever you have in your area, the country or continent, depending on where you are, and they'll get the same type of kerosene you would dump into a kerosene type heater. Like a garage heater or